Good morning, students. Today, let us proceed our chapter, The Human Eye and Its Colorful World. And we will proceed towards our topic, that is scattering of light. Scattered means to move all directions. The light is moving in all the directions and we see some color, that means it is reason behind that. So when white light falls on various types of suspended particles in the atmosphere, it is deviated from its path in random directions. The deviation of light from its path to random directions or in all directions is scattering of light. You students know that in our atmosphere different size of particles are suspended which is comparable to the wavelength of visible light. For example, if the size of the particle is 4 into 10 to the power minus 7 meter to 7.5 into 10 to the power minus 7 meter, and when white light falls on that particular size of the particle which is almost equal to that particular wavelength, then below that all the color will scattered and above that wavelength the color will not scatter. So finally it depends upon the size of the particles. Now I am showing you here. The color of scattered light depends on size of scattering particles. So violet color have almost 400 to 450 nanometer, indigo color 450 to 480 nanometer. Like this, if you will go up to red color 650 to 750 nanometer, that means wavelength increases from violet color to red color. Now, if in the atmosphere greater than the size of this red color particles is present, suppose in the cloud water droplets are present which is almost equal to 0.2 millimeter, or nitrogen molecule size, oxygen molecule size 0.2 millimeter. Now when on these particles the light will falls, white light is incident, then all the color will uniformly scattered and again they mix up and we see the cloud is white colored. Similarly, if in the atmosphere a very small particle is present, that means less than the size of the violet color, that is wavelength of violet color, then what happens? No color is scattered, all is absorbed. So we see that black color. So if no atmosphere is present, we see dark color or black color. So here we are seeing that almost these particles present in the on the size of its own, which is comparable to wavelength of the visible light. Now here what happens again? We see sky seems to be blue color. Then what? If in the atmosphere the size of the particle is almost 480 nanometer, then what will happen? Whatever the light is incident on these particles, violet is scattered, indigo is scattered and blue is scattered mostly, and we will see that the sky seems to be blue color because violet scattered and finished, it does not reaches to us. Indigo a very little bit reaches to us and blue color reaches to us. Our eyes can be able to see that blue color, so sky seems to be blue color. Then at noon what happens? At noon sun is on our head, that means it has to travel very less distance. At noon events the particles are polluted, that means pollution increases, so size of the particles increases. So if size of the particles increases comparable to the wavelength of red color, then whatever the light falls on this, it is equally, uniformly scattered, and almost in the noon we see sky seems to be white color, a little bit blue color if size of the particle blue color is more than this one. Now come student, let us see Tyndall effect.